We are in section 7.3, everyone. The last section of chapter 7. To finish off, we're going to look at theory-based approaches to analyzing paired data. We did simulations in 7.2. Now we're going to work with theory. Remember, theory-based approaches are beneficial because my simulations would be different than yours. Your simulations would be different than your neighbor's. So you would get different results, slightly different results than me. I would get slightly different results than your neighbor. How can we come to a consensus when all of our results are a little bit different? Well, we can come to a consensus using the theory-based approaches. You cannot always use theory-based approaches as we've learned in chapters 1, 2, 5, and 6. We need to make sure some conditions are satisfied. These conditions are called validity conditions. In chapter 7, the validity condition is the following. The null distribution needs to be centered at the hypothesized value of the long-run mean difference. So if we were, this hypothesized value means that we need the null distribution to be centered at 0. That is our hypothesized value according to the null hypothesis. Also in statistical terms, the variability of the null distribution needs to depend on the sample size. So remember, if we have a larger sample size, we'll have less variability and our distribution will be more narrow. It also needs to depend on the sample differences and how variable or spread out they are. Well, how do we know if these two conditions will be met? We just need at least a sample size of 20 or more. So we need at least 20 pairs. Also, the distribution of the sample's differences can't be strongly skewed. You don't want a distribution that looks like this. That's a right skew. Or we don't want a distribution that's like this, which is a left skew. We don't want pretty much everything on the left side for a left skew, pretty much everything in the hump on the right side for a right skew. Instead, we want a distribution that's about symmetric. Yay. So these two conditions are the validity conditions that need to be met. I'll save that as well. Okay, so if these validity conditions are met, we can use theory to find first our standardized statistic. Remember the general template of the standardized statistic. You take the sample statistic minus the hypothesized mean of the long run mean of the differences divided by your standard error. You can see that the sample statistic is the observed mean difference of all the pairs. Sample mean difference is x bar d, the observed mean difference of the pairs in your sample. you get the hypothesized long-run mean difference of 0 because of your null hypothesis. Put 0 up on the top right. And then your standard error is a sample standard deviation divided by the sample size. Sample size is the number of observed pairs in your data, and then the sample standard deviation will be given to you in the question. Those are all the pieces you need to find the standardized statistic. And then you'll use the same strength of evidence guidelines you're used to. Those strength evidence guidelines are best found in chapter 1. So if your standardized statistic is far away from 0, then you're going to have more evidence against the null hypothesis. If your standardized statistic is closer to 0, you have weaker evidence against the null hypothesis. Hey, here's the strength of evidence guidelines. You can just review them here too. Remember, if you have little to no evidence against the null hypothesis, that means you'll most likely fail to reject the null hypothesis and say that the null hypothesis is plausible. You won't say that the null hypothesis is true, just say that it is probably true. Just in case you're curious, these vertical bars around the t is called the absolute value. It can just take any negative number and make it a positive. So if you have a standardized statistic between negative 1.5 and positive 1.5, then you have little to no evidence against the null hypothesis. You can also find a confidence interval using theory. You take the sample statistic, sample mean difference, you plus or minus a multiplier times the standard error. Remember this. What is the multiplier times the standard error? That, bad circle, oval. The multiplier times the standard error is the margin of error. Please remember that, don't forget it. So the margin of error has two parts. The standard error is one part, and then the multiplier is the second part. So if you want to visualize the confidence interval, you start at the sample mean difference. And then you minus off the margin of error. And you get your lower bound. Then you plus the margin of error. Here's a minus margin of error on the left, and then a plus margin of error on the right. That's not really a symmetric confidence interval, is it? Okay, you plus the margin of error to get your upper bound. All of the values between the lower bound and the upper bound is your confidence interval. Okay. And you can look at the previous slide to know what will each symbol be in my problem. I'll save my work. If you want to interpret the confidence interval, you can state the confidence interval in words by first saying, I am 95% confident. If you want to talk about 95% confidence intervals, I am 95% confident the true mean difference of the response variable between group 1 and group 2 is within the interval blank and blank. This template is good for you to memorize. You'd use this template for the context of your study. So you'd replace the response variable with the response variable of study. Group 1, whatever that is in your study, and group 2, whatever that is in your study. You'll put the lower bound for the first number of the interval and the upper bound for the last number in your interval. Second thing you'll do when you interpret intervals, you'll say, is 0 in my confidence interval? If it's not in your confidence interval, 0 is not a believable value. What will you do? You'll reject the null hypothesis and conclude that the alternative hypothesis is true. If 0 is actually in the interval, yes, you're going to say 0 is a believable value for the parameter. Therefore, you will fail to reject the null hypothesis because it is still a plausible explanation for your parameter. So you can see you're going to use the same skills that you've used in previous chapters for the confidence interval and the standardized statistic. The new parts is that you're going to use new symbols, new parameters, and new sample statistics. This class is all about recycling, so you just need to memorize important parts to reuse for later. Now finally, we want you to do Exploration 7.3. Obviously your groups aren't handy to you right now, so please do Exploration 7.3 on your own. We will give you good feedback so you can understand what are right answers, what are good strategies for you to use in preparation for future assignments and the final exam. So good luck, and we will talk to you later. Bye.